Okay, so welcome everybody to today's Virtual Mentors Club live stream. Today will be a third grade math live stream, and I will be going over the TEKS 3.3a, 3.3b, and 3.3c for math. So please let me know in chat if you can hear me, and we will get started shortly. So please let me know in chat if my audio is working, and we will get started in just a couple minutes. Okay, so I think my audio is working. For anyone that's just joining the stream now, welcome to the stream, and today I will be doing the third grade math TEKS of 3.3a, 3.3b, and 3.3c, and we will get started in just a little bit. So today, two of the problems are from past STAR tests, and one of the TEKS, I believe 3.3b, was not available in any of the recent STAR tests, so I was able to find a problem for that from an outside resource, but it is still in the same format that a STAR question will be in. So it's 5:35, so let's get started with the stream. So the concept that all of today's problems will be going over is fractions and the basic idea of what a fraction is and how to identify the value of a fraction using diagrams and things like that. So what is a fraction? First of all, I'll just quickly show how fractions work, just the basic idea of them. So what a fraction is a fraction is, I'm going to write it here on the screen, a part over a whole. Now, what does a part over a whole mean? Pretty much, it's when we have one whole and we split it up into equal parts, and we're pretty much identifying how many parts of the whole are shaded. So let me just draw an example. So let's say we have a circular pizza here. I'm just going to draw a circle for this pizza, and we're going to cut it into two equal slices. Now my drawing's not going to be perfect, but let's say we cut it into two of these equal slices. And we were to shade in, choose a different color for this, we were to shade in just one of these two slices. What would the fraction be? So, as we wrote earlier, let me just box this in. A fraction is written as a part over a whole. So, how many parts do we have? We have one part that's shaded out of the two parts. So, our part on top is a 1. Then we put a fraction bar. And then under the fraction bar for the whole, we have to see how many total parts are there in the whole. So in this case, we have two parts. The one that's shaded and the one that isn't shaded. So that's 2. So the way that we would write this as a fraction is 1 over 2. Let me just do another example quickly. Let me just erase what I've just drawn. And let's say we have, again, let's just say we have another pizza here. But this time, we were to cut it into 4 slices. 4 equally sized slices. I know my drawing isn't perfect, but let's just say that these are all equally sized slices. And this time, let's shade in this slice, and this slice. Here, we would say, how many parts are there? Well, we have 3 shaded parts, which we can just count up. We can see there are 3 shaded parts. So that's 3. We put the fraction bar under the 3. And there are 4 total parts. So we put a 4 on the bottom to represent the whole. The whole has 4 parts. So we would represent this as the fraction 3/4. So now let's get started with this problem right here. This is the first problem from, I believe, the 2016 Math Star. And this is the T3.3a. So Anissa shaded part of the figure shown below. What fraction of the figure is shaded? So let's go and highlight the most important parts. So she shaded part of the figure shown below. That's important. And what fraction of the figure is shaded? It's important to remember. It's asking what's shaded. It could ask us what fraction is not shaded. But here it's asking us what is shaded. So let's just start counting. Let's first see if all of the parts are equal. That's first important. And in this case, we can see that all of the parts are pretty much the same size. They're all equally sized triangles. And here we don't have a circle. It doesn't always have to be a circle. The whole can be any kind of shape. But here we have a more star-like shape that's split into different triangles. So let's do the part first. How many parts are shaded in? Now let's just take red here. We can just start numbering them. We have 1, 2, 3, 4, 5, and 6. We have 6 parts of the figure that are shaded. So we would put 6 as the part. Now remember, we put the fraction bar under. And then now we can count up. Let's make it a little more colorful. We'll put the numerator in red since we counted those in red. We have the fraction bar. And then let's use blue now to count up how many total parts there are. So we have 1, 2, 3, 4, 5, 6, 7, 8, and here we're back to our first part. So we have 8 total parts. So there are 8 total parts in the whole. So right here, this right here is our fraction. Just 6/8. We can say this as 6/8 or 6/8. Those are both ways that we can say this fraction. So now we just need to go through the answer choices and see if any of them say 6/8. Answer choice A, 6/8. It already says that. So we know that this is our answer. Now let's just go through the rest. B, 1/6. We cannot have that because we first of all counted that there are 8 total parts and not 6. So we know that that's wrong. 2/8. Now this one did get the part right, that we have 8 total parts. But this one says that there are 2 parts shaded, which is not true. We have 6 parts shaded. Now this would be the correct answer if, let's say, it asked us what fraction of the figure is not shaded. If we write in green the number that aren't shaded, we just have this part and this part. That's 2 parts. So C would be the answer if it's asking for what fraction of the figure is not shaded. But here it's asking us what fraction of the figure is shaded. So that is incorrect. And answer choice D is 2/6. And again, we know that there are 8 total parts in the whole and not 6. So that is incorrect. So we know that our answer to this problem is A, 6/8. So does anybody have any questions about this problem? So I will just wait until 5:43. If there's any questions, then please leave them in the chat. So it doesn't look like we have any questions so far about this problem. So let's move on to our next problem. So this next problem here is 3.3b. Problem above is actually a 3.3a problem also. Maybe we can come back to it if we have time, which I think we might have time today because we have overall shorter problems, I'd say. There's less calculations required. It's just more of understanding the concept of fractions. So let's just read this problem. The point on the number line represents the location on the football field where the Tiger football team will line up for the next play. And then we have a number line here showing us a point on the football field where they will line up. And the question asks, which fraction represents the distance down the field where the team will line up? So this time we have to take something from a number line and put it as a fraction. So first, of course, let's highlight what's important. Second, let's first zoom back in to this problem here. I don't know why it keeps doing that, but let's just work with this now. So saying the point on the number line, so it's a point on the number line, represents the location on the football field where it will line up for the next play. So that's what you're doing. Which fraction represents the distance down the field where the team will line up? So you might be thinking, how would we use a number line to make a fraction if a fraction is a part over a whole? Well, we can take this number line and we can draw a figure on top of it. So this time we can just say we have a rectangle that was cut into different pieces here. So we can just turn this entire thing into, that was a bad line there, let me just redraw that. Just turn this whole thing into a rectangle. And we can cut it along each of the marks on our number line, because we talked about this in, I believe, either the last live stream or the one before that. But on the number line, each mark is equally spaced. So we can make a mark here, a mark here, a mark here, and here we have our equal parts. Now, remember, a number line counts up from the left to the right. So if we're trying to say what fraction represents the distance down the field, we have to take all of the parts from 0 all the way until our point. So if we use red to shade in our parts, we can say we have this part shaded in since it's before our point, which is, let me just darken it in blue right here. That is our point right there. So we also have this part, we can shade it in because it's before our point. And we can also shade in this part. It's also before our point. And we've gone all the way until the point. If we were to shade in the next one, we'll go past the point. So we're not going to shade that in. And right here, we again have a diagram that shows parts of a whole. So let's just count them up and turn it into a fraction. So how many parts are shaded in? We have 1, 2, and 3 parts shaded in. So that is 3. Then we put a fraction bar under the parts. And then now we see how many parts there are total in the whole. So here, maybe on top we can count up. We have 1, 2, 3, 4 parts. So we have 4 parts in the whole. And right here, we've got our fraction for this problem. 3 over 4, which can also be said as 3/4. So now let's just see where that is on our answer choice. It's not 2/4 because that would mean that we only have 2 shaded in. It's not 4/4 because that would mean that we have all 4 parts of the whole shaded in. It's not 1/4 because that would mean that we only have 1 part of the 4 parts shaded in. And we calculated that is 3/4 because we have 3 out of the 4 parts shaded in. So that is how we do this problem. So does anybody have any questions about how to do this one? I will wait just about a minute just to see if anybody has any questions. Okay, so it doesn't look like we have any questions, so we will continue on and move on to our last problem. And this one is from the 2019 Math Star, and it is problem number 17. And this is the TEKS 3.3c. So let's just start reading the problem. And it says, models R and T are shown. And it shows us 2 of these diagrams, which are just circles with parts of them shaded in. And it's asking which statement is true. So in this case, sorry about that. Just trying to readjust this. I don't know why it's doing that. But I hope that's just behaving kind of weird. But here, I think that's better. So we have models R and T. Those are important. And it's asking us for which statement is true. Why is it not? Okay, I don't know why it isn't switching properly. It's asking us which statement is true. So let's just remember one thing about fractions, because there's one thing that we should be able to see in model R that's just a little bit awkward, and that is the fact that the different parts are not equal. And it's really difficult to make a fraction with unequal parts. Like, we can only get an accurate fraction if all of the parts of the whole are the same size. Because otherwise it just becomes inaccurate if we just say we have whatever number of parts we have shaded in over the total number. Because we can see right here that the shaded part is pretty large. And then these two, I'm going to write 2 and 3. These two are a little more medium sized. And then these parts 4 and 5 are way smaller than the rest. So we could just, like that, if we just say how many parts over the total number of parts there are, it would be 1 out of 5 total parts. But because the parts aren't equally sized, that's not the correct fraction. But on Model T, as we can see, we do have 5 equally sized parts, and it is 1/5 here, because we have one part shaded in out of 5 total parts, which we can just count up. So let's just start looking at some of these answer choices and seeing what's right and what's wrong. So answer choice A says, the shaded parts of model R and model T are different sizes, but each model represents the same fraction of the whole. So the shaded parts are different sizes. As we can see, the one on model T, the one on model R, the shaded part of model R, is a lot larger than the shaded part on model T, just looking at it. So we know they're different sizes, but we also do know that they do not represent the same fraction of the whole. Because if both of the wholes are the same size, and we have a larger section shaded on model R, then that means that the part of the whole is not the same. And we know that because on model R, the parts aren't equally sized, we can't accurately judge that that's 1/5. We know that model T is 1/5, but we don't know model R is 1/5. So because of that, we can say that this is wrong. They do not represent the same fraction of the whole. Answer choice B says, the shaded part of model R cannot be written as the fraction 1/5 because the parts are not all equal in size. And that's true. That's what we were just talking about. In order to write a fraction accurately, all the parts have to be equally sized. If the parts are different sizes, we cannot write that as a fraction. And because of that, and because that's what answer choice B is telling us, this could be the right answer. It's true. Answer choice C says, the shaded part of model T is 1/4 because the parts are all equal in size. This, we know it's wrong because there are not 4 total parts, there are 5 total parts. So the fraction is 1/5, like we wrote above. So we know that this one's false. And answer choice D says, the total number of parts in model R is 5. So 1/5 of model R is shaded. There are 5 total parts, but they're not equally sized parts. So we can't say that 1/5 of model R is shaded. So we can say that's wrong. And just in case you guys are a little bit confused over what I mean with like the equal parts and how that means that they're not equal, let's just redraw model R with equal parts. So if we make a circle similar to model T over here to the side, just make this circle and let's divide it into parts like model T did. So that's something like this. This is a lot more similar to how model T divided up. And if we were to shade in the same part that's shaded in model R with green, so that's all of this in model R is shaded in, that would be all of this here. All I did is that I took model R and I just pretty much redrew that right here. This is also just model R, just with the parts divided differently. So just from doing that, we can see here, if we were to say how many parts are there over the whole, we have 2 shaded parts out of 5 total parts. When we split into equal parts, we can see that the fraction represented by model R is actually 2/5. Not 1/5. So again, if we revisit the ones that we marked as wrong, answer choice A says the shaded parts of model R and T are different sizes, but each model represents the same fraction of the whole. Well, model R represents 2/5 and model T represents 1/5. So that means that they are not the same fraction of the whole. Answer choice C, which we also marked as wrong, says the shaded part of model T is 1/4 because the parts are all equal in size. This again has nothing to do with model R. We already calculated that model T has 1 out of 5 total parts shaded in, so the fraction has to be 1/5. And for answer choice D, it says the total number of parts in model R is 5, so 1/5 of model R is shaded. But when we redo this diagram, we could actually see that there are 2 parts shaded out of the 5 total parts. So it's actually 2/5 that is shaded. So Just like that, we can reinforce that A, C, and D are all wrong. And if we go back and look at answer choice B, which we said could be the right answer, the shaded part of module R cannot be written as a fraction 1/5 because the parts are not all equal in size. And that's right, because the parts were unequal in size, if we had written 1/5, that would have been wrong. When we made the parts equal in size, right here, let me just circle this new diagram we made right here. Here, when we made the parts equal, we saw that the fraction is actually 2/5. And that's pretty much what answer choice B says. It's not 1/5 and it's something else. And we got that something else is 2/5. So because of that, answer choice B is the correct answer here. Does anybody have any questions about this problem? I will wait just about another minute just to see if anybody has any questions about this. Okay, so with that, I think we don't have any questions about this problem, and I think with that we will end today's stream. So thank you everyone for watching today's stream. We will be back with more streams tomorrow on the channel, so be sure to be looking out for that. And we will be continuing to look at more fractions tomorrow as well. For all of you third graders out there, we will be going more into fractions with TEKS 3.3D, 3.3E, and 3.3F. So thank you everyone for watching.